On April 10, 2026, 4 humans came home from the moon. They had not landed on it. They had not orbited it for long. They had simply gone, flown around its far side, photographed regions of the lunar surface no human had ever seen with their own eyes, and turned back toward Earth. By the time the Orion capsule splashed down in the Pacific Ocean off San Diego at 8:07 p.m. Eastern Time, they had traveled 2,156 miles from Earth. That is farther than any human being has ever traveled in the history of our species. The previous record had stood since 1970. It was held by the crew of Apollo 13. In the next 13 minutes, we'll walk you through exactly what happened on Artemis II, the 8.5 million pounds of thrust that lifted them off the launch pad, the 3-day coast through the lunar transit, the 7-hour flyby of the moon's far side, which had not been seen by human eyes since 1972, the 5,000-degree re-entry that pushed Orion's heat shield to the edge of its design, and the question that matters most, what this mission actually proves and what it doesn't. To understand why Artemis II matters, you have to understand what it isn't. It is not a moon landing. The crew never touched the lunar surface. It is not Apollo. The technology, the goals, and the era are completely different. What Artemis II is, and this is the part that mainstream coverage tends to miss, is the first time since 1972 that human beings have left low Earth orbit. Not for resupply missions, not for satellite repair, not for the International Space Station. Truly left. The 53-year gap is now closed. The mission began at 6:35 p.m. Eastern on April 1, 2026. Launch Pad 39B at the Kennedy Space Center held the largest rocket NASA has flown since the Saturn V. The Space Launch System, or SLS, generates 8.8 million pounds of thrust at liftoff. That is roughly 15% more than a Saturn V. It is the most powerful operational rocket in the world. The 4 crew members, NASA astronauts Reid Wiseman, Victor Glover and Christina Koch, and Canadian Space Agency astronaut Jeremy Hansen, were strapped into the Orion capsule perched on top of it. They had named the spacecraft Integrity. At T0, 4 RS-25 main engines and 2 solid rocket boosters ignited simultaneously. Within 8 seconds, the rocket cleared the tower. Within 2 minutes, the solid boosters separated and fell back toward the Atlantic Ocean. Within 8 minutes, the core stage was empty and the crew was in low Earth orbit, traveling at roughly 17,500 miles per hour. This is the easy part. Getting to low Earth orbit is something humans have done routinely since the 1960s. The hard part was still ahead. After 1 full orbit of Earth, Mission Control gave the command for what is called the Trans-Lunar Injection Burn. The upper stage of the SLS reignited. For 18 minutes, it accelerated Orion from 17,500 miles per hour to over 22,000. That extra 5,000 miles per hour is everything. It is the velocity required to escape Earth's gravity. From this point on, the spacecraft was no longer orbiting Earth. It was falling toward the Moon. The same trajectory Apollo 8 took in 1968. The first humans to leave in over half a century. For the next 3 days, the crew did something that no astronaut had done since the Apollo era. They coasted. There is no thrust between Earth and Moon, not for ordinary spacecraft. The Trans-Lunar Injection Burn provides all the energy needed. After that, it is pure orbital mechanics. The spacecraft slows as it climbs out of Earth's pull, then accelerates into the Moon's. During this transit, the crew tested Orion's life support systems and ran biological experiments, including one called Avatar, which studies deep space radiation. This studies how human tissue responds to deep space radiation outside Earth's protective magnetic field. Astronauts are the first humans in 53 years to experience it again. Beyond the magnetic field, protection disappears. Solar particle events and galactic cosmic rays hit the spacecraft directly. Apollo astronauts experienced this. Now Artemis II does too. The data Orion collected during transit will shape every Mars mission that follows. We are learning how to survive the long journey across the solar system. On April 6, 2026, the crew reached the Moon. The trajectory carried them around the lunar far side, the side that always faces away from Earth, the side the rest of us never see directly. For 7 hours, the crew photographed regions of the lunar surface that had not been seen by human eyes since the Apollo 17 crew left in 1972. During the flyby, the crew was 250 to 756 miles from Earth. That is farther than the previous record set by Apollo 13 in April 1970. Artemis II broke it. During the flyby, the crew also captured an image that will likely become one of the defining photographs of the 21st century. It echoed an image from 1968, the famous Earthrise photo taken by the crew of Apollo 8, where Earth appears as a small blue marble rising over a stark grey lunar horizon. The famous Earthrise photo taken by Apollo 8. The Artemis II version was taken with modern cameras, Earth fragile and small above the curved limb of another world. The Apollo 8 Earthrise photograph is widely credited with helping launch the modern environmental movement. What this new Earthrise will do remains to be seen. But the symbolic weight of it, humans returning to a place they had abandoned for half a century, looking back and seeing the same thing, is hard to overstate. Humans returning to a place they had abandoned for half a century, looking back and seeing the same thing, our only home floating in the void. Three days later, on April 10th, the crew was approaching Earth at 24,500 miles per hour. At that speed, hitting the atmosphere is violent. Air molecules compress in front of the heat shield to temperatures of nearly 5,000 degrees Fahrenheit, roughly half the surface temperature of the Sun. For 6 minutes, the spacecraft is wrapped in plasma, so dense, radio signals cannot pass. Ground controllers lose contact. They wait. And they wait. At 8:03 p.m. Eastern, drogues deployed, then the mains. The capsule decelerated to a rate gentle enough for human passengers. Splashdown was imminent. At 8:07 p.m., Orion splashed down in the Pacific Ocean. US Navy divers were in the water within minutes to assist the crew. Within an hour, all 4 crew members had been hoisted by helicopter to the USS John P. Merthyr. They underwent immediate medical evaluations. They were photographed walking off the deck. They flew to Houston the next day. The mission lasted 9 days, 23 hours and 32 minutes. Total distance traveled, 694,181 miles. Heat shield, intact. Crew, healthy. The first crewed lunar mission of the 21st century had succeeded. What does Artemis II actually prove? First, the obvious. The SLS rocket works at full operational thrust with crew aboard. The Orion spacecraft can sustain 4 humans through deep space transit, lunar approach, and re-entry. Communications, life support, navigation, manual piloting, and recovery systems all performed as designed. By itself, this is the largest set of human-rated deep space hardware validated in 53 years. That alone is a monumental achievement. The heat shield survived a real re-entry under real conditions. Life support, navigation, and manual piloting all performed as designed. This is a monumental achievement. But here is what Artemis II does not prove. It does not prove that NASA can land humans on the Moon. That requires Artemis III and a commercial lunar lander. It does not prove a sustainable presence. The Lunar Gateway was cancelled in March 2026. The architecture for staying is still being redesigned. And it does not prove we can go to Mars. Radiation and duration are an order of magnitude beyond this mission. It is a beginning, not a completion. Artemis II proved that human deep space flight is possible again. It did not prove it is easy. It proved we can rebuild the legacy of Apollo. The 53-year gap was not just a calendar gap. It was a measure of how hard it is to maintain the capability to leave our home planet. We didn't lose the knowledge. We lost the will to fund it, the industrial base to build it, and the political consensus to pursue it. Getting it back required all three. We are finally back. Reid Wiseman, Victor Glover, Christina Koch, and Jeremy Hansen flew the mission. But it was made possible by 50 years of accumulated decisions to try again. Subscribe. We explain the hidden engineering, biology, and physics behind the things you see every day.